Welcome to Technology Comparison's Crashcasts. I'm your host, Sheila, and today we're diving into the world of configuration management tools, specifically comparing Chef and Puppet. Joining me is our expert, Victor. Welcome, Victor.
Thanks for having me, Sheila. I'm excited to discuss these powerful tools that have revolutionized IT infrastructure management.
Great. Let's start by outlining the sections we'll cover in today's episode. We'll begin with a brief history of configuration management tools, then dive into the basics of Chef and Puppet. We'll compare their architectures, languages, and use cases, and discuss their strengths and weaknesses. Finally, we'll explore best practices and future trends. But first, let's kick things off with a quiz question for our listeners.
Sounds like a comprehensive plan. I'm ready when you are.
All right. Here's the quiz question. Which configuration management tool, Chef or Puppet, uses a pull architecture by default? Victor, any thoughts on this without giving away the answer?
That's an interesting question, Sheila. It touches on a fundamental aspect of how these tools operate. The choice between push and pull architectures can significantly impact how systems are managed and updated. I'm curious to see how many of our listeners know the answer.
Indeed. We'll reveal the answer later in the episode. Now let's start with the history of configuration management tools. Victor, can you give us a brief overview of why these tools were created and how they've evolved?
Certainly. Configuration management tools emerged in the early 2000s as a response to the growing complexity of IT infrastructure. As organizations scaled up their operations, manually configuring and maintaining servers became increasingly time-consuming and error-prone. These tools were created to automate the process of configuring, deploying, and managing servers and applications. Chef was first released in 2009, while Puppet came a bit earlier in 2005. Both tools aimed to solve similar problems, but took different approaches. Over time, they've evolved to include more features, better integrations with cloud platforms, and improved user interfaces.
That's fascinating. So these tools have been around for over a decade now. Can you explain the basic concept of configuration management for our listeners who might be new to this topic?
Of course, think of configuration management like a recipe for your computer systems. Instead of manually setting up each computer or server, you write down the instructions once. Then the configuration management tool follows these instructions to set up all your systems exactly the same way, every time. This approach, often called infrastructure as code, makes it easier to manage large numbers of computers consistently and reproduce environments reliably.
That makes sense. So, how do Chef and Puppet fit into this concept? What are the main differences between them?
Both Chef and Puppet are configuration management tools, but they have some key differences. First, they use different languages. Chef uses Ruby, a popular programming language, while Puppet uses its own special language that's designed to be easier for non-programmers to understand. Second, they have different ways of updating systems. Chef primarily uses a method where computers check for updates on their own, while Puppet can work both ways. Computers can check for updates, or updates can be sent out to them. Third, Chef might be a bit harder to learn if you're not familiar with programming, while Puppet's approach can be easier for beginners to grasp. Lastly, Chef is often considered more flexible for complex setups, while Puppet is great at keeping things consistent across many computers.
That's a great overview. I'm curious about the different ways of updating systems you mentioned. Can you elaborate on that?
Certainly. There are two main ways these tools can update systems: pull and push. In a pull setup, imagine each computer as a student that regularly goes up to the teacher's desk to check if there's any new homework. That's how Chef typically works. Each computer checks in with a central server to see if there are any updates. In a push setup, it's more like the teacher walking around the classroom, handing out assignments to each student. Puppet can work this way, actively sending out updates to computers. The choice between pull and push can affect things like how quickly changes spread through your system and how much network traffic is created.
I see. So, if I understand correctly, Chef primarily uses a pull model, where servers check for updates, while Puppet can do both pull and push. Is that right?
That's a good summary, Sheila. You're on the right track. Chef does primarily use a pull model, although it has added push capabilities in later versions. Puppet, on the other hand, has always supported both models, giving users more flexibility in how they manage their infrastructure.
Got it. Now let's dive a bit deeper into the languages used by these tools. You mentioned that Chef uses Ruby, while Puppet has its own language. How does this affect their usage and learning curve?
Great question. The choice of language significantly impacts how users interact with these tools. Chef's use of Ruby means that if you're already familiar with Ruby, you'll have an easier time getting started with Chef. It's like knowing the local language when you visit a new country. Everything's a bit easier to understand. However, if you're not a programmer, Chef might feel a bit more challenging at first. Puppet's custom language is designed to be more like writing a list of what you want, rather than how to do it. It's often easier for people who aren't programmers to understand. Imagine it like giving instructions to a very smart assistant. You just need to say what you want done, not how to do each step. That said, both tools have evolved over time to become more user-friendly. Chef has introduced ways to write simpler instructions, while Puppet has added the ability to use Ruby for more complex tasks when needed.
That's really helpful, Victor. It sounds like the choice between Chef and Puppet might depend on the team's background and the specific needs of the project. Are there particular use cases where one tool might be preferred over the other?
Absolutely, Sheila. While both tools can handle a wide range of configuration management tasks, they do have areas where they tend to shine. Chef is often favored in environments where flexibility and customization are key. It's popular among development teams and in DevOps cultures where there's a strong emphasis on code. Chef's tight integration with Ruby makes it powerful for complex programmatic configurations. It's also well suited for organizations that are heavily invested in the Ruby ecosystem. Puppet, on the other hand, is often chosen for large-scale infrastructure management, especially in enterprise environments. Its approach of describing what you want, rather than how to do it, makes it excellent for ensuring consistency across thousands of servers. Puppet is also known for its strong reporting capabilities, which can be crucial for auditing and compliance purposes. That said, these are general trends, and both tools are versatile enough to be used in a variety of scenarios. The best choice often depends on factors like team expertise, existing infrastructure, and specific project requirements.
That's a great explanation, Victor. It really helps to understand the strengths of each tool. Now, I'm curious about real-world implementations. Can you share some examples of how companies are using Chef and Puppet in production environments?
Certainly. There are many notable companies using both Chef and Puppet in production. For Chef, some well-known users include Facebook, IBM, and Nordstrom. Facebook, for instance, uses Chef to manage its vast infrastructure, including tens of thousands of servers. They've even shared some of their Chef recipes with the public. Puppet, on the other hand, is used by companies like Google, NASA, and CERN. Google uses Puppet to manage its cloud platform, ensuring consistency across its massive infrastructure. CERN, the European Organization for Nuclear Research, uses Puppet to manage the computing infrastructure that supports its scientific research, including the Large Hadron Collider. Both tools are also widely used in smaller organizations and startups. For example, many companies use Chef or Puppet to manage their cloud infrastructure on platforms like AWS, Azure, or Google Cloud, ensuring consistent setups across development, testing, and production environments.
Those are some impressive use cases. It's amazing to think about these tools being used to manage infrastructure for projects as complex as the Large Hadron Collider. Now, I'm sure there are some common misunderstandings or pitfalls when using these tools. Can you share some of those and how to avoid them?
Absolutely, Sheila. There are indeed some common pitfalls that users of both Chef and Puppet should be aware of. 1. Overcomplicating configurations. It's easy to get carried away and create overly complex setups. Keep things simple and modular where possible. 2. Ignoring idempotency. Both tools are designed to produce the same result regardless of how many times they're run. Failing to write code that works this way can lead to unexpected results. 3. Not version controlling configurations. Treat your infrastructure code like any other code and use version control. 4. Neglecting testing. Just like application code, infrastructure code should be tested. Both Chef and Puppet have testing tools available. 5. Misunderstanding the scope. Some users try to use these tools for tasks they're not well suited for, like real-time application deployment. Understanding the appropriate use cases is crucial. To avoid these pitfalls, it's important to follow best practices, invest in proper training, and start with small, manageable projects before scaling up.
Those are great points, Victor. It's clear that while these tools are powerful, they require careful use and understanding. Speaking of best practices, do you have any tips or tricks for users of Chef or Puppet?
Certainly. Here are some best practices that apply to both Chef and Puppet. 1. Use roles and profiles. Organize your code into roles, what a system does, and profiles, how it does it, for better modularity and reusability. 2. Leverage community resources. Both Chef and Puppet have extensive libraries of pre-written modules or recipes. Use these to avoid reinventing the wheel. 3. Keep secrets secure. Use encrypted storage in Chef or Puppet to manage sensitive information securely. 4. Implement a testing strategy. Use tools like Test Kitchen for Chef or Beaker for Puppet to test your configurations before applying them to production. 5. Monitor and log. Implement robust monitoring and logging to track changes and troubleshoot issues. 6. Use version control. Always keep your configuration code in a version control system like Git. 7. Document your code. Good documentation is crucial, especially for complex configurations or in larger teams. Remember, the goal is to create maintainable, scalable, and reliable infrastructure code.
Those are excellent tips, Victor. Now, before we wrap up, I'd like to reveal the answer to our quiz question. The question was, which configuration management tool, Chef or Puppet, uses a pull architecture by default?
Ah yes, the quiz question. I'm excited to hear the answer.
The answer is, Chef uses a pull architecture by default. While Puppet can operate in both pull and push modes, Chef was primarily designed around the pull model, where systems periodically check in for updates.
That's correct, Sheila. It's an important distinction that can impact how these tools are implemented in different environments.
Indeed it is. Now, let's summarize the main points we've covered in this episode. 1. Both Chef and Puppet are powerful configuration management tools that help automate infrastructure management. 2. Chef uses Ruby and is often favored for its flexibility and customization capabilities. 3. Puppet uses its own language and is known for its declarative approach and strong reporting features. 4. The choice between Chef and Puppet often depends on factors like team expertise, existing infrastructure, and specific project requirements. 5. Both tools are used by major companies to manage large-scale infrastructures. 6. Common pitfalls include overcomplicating configurations and neglecting testing. 7. Best practices include using roles and profiles, leveraging community resources, and implementing robust testing strategies. Victor, is there anything you'd like to add to this summary?
That's an excellent summary, Sheila. I'd just add that both tools continue to evolve, with newer versions introducing features to address their traditional weaknesses. It's always worth keeping an eye on the latest developments in this space.
Great point, Victor. If we had more time, we could have delved deeper into the latest features of both tools, discussed alternative configuration management tools like Ansible or SaltStack, or explored how these tools integrate with container technologies like Docker and Kubernetes. To our listeners, thank you for tuning in to this episode of Technology Comparisons Crashcasts. If you found this information helpful, please subscribe to our podcast and leave us a rating. Your support helps us continue to produce valuable content. Until next time, keep learning and happy configuring.